Welcome to EDU World Space.
This is chapter 21, problem number 28. We're asked to calculate the magnitude and direction of an electric field midway, at a point midway between two charges. Q1 equals negative 8 microcoulombs and Q2 is 5.8 microcoulombs. And these two charges are 8 centimeters apart. Now, let's draw our Q1, negative 8 microcoulomb. And then we have Q2, it's 5.8 microcoulombs, and the line that connects them to each other, this is 8 centimeters, right? But we're asked the magnitude of the total electric field at a point between the two, the middle point, right? So then it divides this R into two halves. So this first portion being 4 centimeters, R over 2, and the second portion being also 4 centimeters. All right. Now, how are we going to determine the electric field, total electric field at this point, right? That's the question. First of all, we're going to have two contributions, right? Q1 is going to generate its own field at this particular point, and Q2 also is going to generate its own electric field. We know how to calculate the magnitudes, right? We remember the electric field equation. The magnitude of the electric field is K, Q over R. So R being the distance from the point that you're interested in to where your charge is, Q is the amount of charge. However, let's just talk about the directions. If we have a negative charge, the electric field that a negative charge generates is always going to be towards the charge itself. So if we want to call the electric field generated by Q1 E1, then it's going to be, E1's direction is going to be pointing the negative charge. Now, if we have a positive charge at a particular point that we're interested in finding the direction of the electric field, then we have the opposite, right? So the electric field generated by a positive charge is always outwards, radially outwards, right? So then it's going to be away from a positive charge, which makes the electric field also in the same direction as E1. Right? So we have two electric fields at this particular point, the midpoint between the two charges. And in order to calculate the total electric field at that point, what we need is we need to find these individual fields and write them down in the vector form and basically take the summation from the superposition principle, right? So let's write the magnitude of E1 for now. E1 is being the electric field generated by Q1. So it's going to be K. I'm just writing the magnitude. That's why I'm putting the absolute value here. Let's call this distance as R1 squared. You know, well, I'm calling this distance as R1. R1, meaning R1 equals, let's define R2 also. They're equal to 4 centimeters, which is the half of R that is given to us in the problem. Now, this is the magnitude of E1. The direction of E1 is pointing left. So conventionally, for any vector pointing left, we use negative I hat, correct? So I wrote E1 vector now. I'm going to add this to the E2 vector. Let's calculate the magnitude of E2 vector. It's going to be K, Q2, let's put it in the absolute value even though it's positive so that it would be a good exercise for you. And then E2 is also in the negative I hat direction. Now all we need to do is just to plug in the numbers and then figure out what the total electric field is. I'm going to move on to the next page. So E total equals K 8.99 times 10 to the power of 9 Newton meters squared over Coulomb squared. The charge, the magnitude of the charge, it's 8 times 10 to the power of negative 6 coulombs. Again, I did the conversion from microcoulombs to coulombs. In denominator, I have 4 centimeters. I'm going to convert that to meters first and then take the square. Remember, the unit vector was negative I hat. Plus 8.99 times 10 to the power of 9 Newton meters squared over Coulomb squared times the second charge, 5.8 times 10 to the power negative 6 coulombs. I did the conversion again. And denominator, I have the same distance. Again, negative I hat. They're both pointing in the negative x direction. Then from here, we find the magnitude to be 7.8 times 10 to the power 7 newtons per coulomb in negative I hat direction. What does this mean? What did we call negative I hat? It's actually towards the negative charge, correct? So direction is towards the negative charge.